Welcome to Section 2, Learning VMware Horizon 7 Architecture. So what are we going to learn in this first section? Before we start to talk about the specifics of VMware Horizon, we're going to define what we mean when we use the term virtual desktop infrastructure. We're then going to quickly cover a brief history of the VMware VDI products, with the goal of providing you with some of the key background of how the solution has evolved and matured to where we are today. We'll then move on to describe the new features in this latest release of the software and how to license the different versions. Next, we're going to move on to talk about some of the Horizon architecture components and some of the key features that the solution delivers. As part of this, we will describe each part of the solution components and how it works, along with some discussions around the key features that these components offer. By the end of this section, you will have gained a good understanding of how Horizon View and its components all work. So let's start to look at what VDI is first. So when we talk about VDI, or Virtual Desktop Infrastructure, as it's more commonly referred to, we are typically describing a solution whereby the desktop operating system is hosted as a virtual machine running on a hypervisor that in turn is hosted on a server that is part of a data center server infrastructure or a cloud platform. This type of desktop virtualization is sometimes often referred to as hosted virtual desktop. So how does it work? A user connects remotely from their endpoint device, which could be a PC, thin client, or a mobile device, to a thing called a connection broker. This connection broker manages the available resources and connects the user to an appropriate virtual desktop. In the first VDI solutions that came to market, there was no concept of a connection broker, and users would just connect directly to a virtual desktop machine. Once connected, the screenshots of the virtual desktop machine are sent over the network or the internet to the endpoint device using an optimized delivery protocol. And then the mouse movements and the keyboard strokes are sent back to the virtual desktop machine via the same protocol. No data leaves the data center, but instead screenshot updates or pixel changes are sent over the network. It's a bit like watching a smart TV with the pictures broadcast to your television from the TV studios. From an architectural perspective, the virtual desktop typically gets built on demand, bringing together the different components that make up a full desktop. The operating system, user profile, desktop policies, and applications are all treated as separate individual components, abstracted from the underlying machine, and then they're all delivered back together to create a user's desktop experience. You should remember that virtual desktop machines need to be treated differently to physical desktops, and to reap all the benefits of virtual desktop machines, they should be built from the ground up and managed as virtual desktop machines, using some of the tools that have been specifically designed for the management of virtual desktop infrastructure, and we'll talk about that a bit later. VDI sometimes gets confused with server-based computing, or SBC, or even remote desktop services, often called RDS. So what are the differences between these technologies and VDI, if any at all? So let's take SBC and RDS first, as this is the technology that's been around the longest. In fact, you could probably trace it back to the 1950s with the introduction of mainframe technology, which was then designed to deliver centralized compute power to run a set of applications, with the end users connecting to the applications using a green screen terminal, which was just literally that, just a screen and a keyboard. SBC or RDS is seemingly not that different then to VDI in the way it works. You're connecting remotely to an app that is running on server infrastructure. But that's where the similarities end. Let's take delivering applications first. The difference is that the applications are installed and run on the actual servers themselves, and are using a multi-user version of that application to create the individual user sessions. A user would then connect to their own individual separate and protected session of that application, instead of connecting to a full operating system with the application installed upon it. As everything is running in the data center, users would connect to the session using a terminal or thin client again. And in fact, SBC is often referred to as thin client computing. Using this same model, you could also deliver hosted desktop sessions in the same way. Instead of connecting to a full instance of a desktop OS, the user now connects to a separated, protected individual session of the server's operating system. The one thing to note here is that the user is essentially running a server-based OS, such as Windows Server, rather than Windows 10. So what are some of the benefits of deploying VDI? So the first one's around security and compliance. As we've said, no data actually leaves the data center, unless of course the IT department have a specific policy to allow it, such as connecting a USB drive. All that gets transmitted to the client devices are screenshots, and the only data that comes back are the keyboard strokes and the mouse strokes. It's centralized, allowing simplified management. So now everything's held in the data center, it's much easier to perform tasks such as updating and patching an OS, or maybe installing a new app. The virtual desktops are all created from a single gold image that is maintained and updated centrally, so you don't have to visit every physical machine. You can simply update the image, recreate the virtual desktops with a few mouse clicks, and hey presto, all the new users get the new updated versions. Also, troubleshooting is much easier, as you don't need to go and actually physically visit the desk side. With flexibility and agility, by having desktops hosted on a virtual platform, it allows you to scale up and down much more easily, without the need to purchase more physical desktops. You could just use thin client devices or even allow users to connect using their own device. Environments can be spun up quickly and also taken down just as easily to accommodate seasonal workers or contractors on specific products. Users now have access to their virtual desktop machines wherever they are and no longer need to be in the office, at a desk, or have a PC to access their corporate desktop. They can continue to be productive even when they can't make it into the office, if the weather's bad or the traffic's bad, or whichever. Mobile and bring your own device from anywhere. Virtual desktop clients enable mobile devices, tablets and non-corporately owned devices to connect securely to corporate desktops. Following the flexible working theme, users can now choose a device that suits them to access their corporate desktop. Whether that be a tablet, a smartphone, or even a non-Windows platform, users can still have access to their corporate desktop, securely and from a remote location. And then finally, the one that VDI tackles, operational cost savings. Implementing a virtual desktop environment and adopting operational best practice around image, patch and profile management with the centralized application deployment will result in some savings in operational expenditure, or OPEX, compared to traditional desktop management. Capital expenditures, or CapEx, are still required to support the virtual desktop environment, such as the infrastructure. One of the things that I hear all the time is that by deploying VDI, it will reduce my costs. But it's worth noting that yes, it will reduce your OPEX, but typically the CapEx at the beginning of a VDI project will be somewhat higher as you have all the infrastructure to deploy. Overall though, the costs will reduce through savings in the management of the solution, and you will not also be caught in that 3-year PC desktop recycle. So let's get into specifics of VMware Horizon 7 and introduce you to VMware's solution for the delivery of virtual desktops. So we're going to start with a bit of a history lesson as to where it started for VMware. So the concept of virtualizing Windows desktops has actually been around since 2002, when VMware customers started virtualizing desktop workloads and hosting them on a VMware server and ESX servers in the data center. As there was no concept of a connection broker at that time, and neither was the phrase VDI really used, to be honest, customers simply connected using the RDP protocol directly to a dedicated desktop, which was typically then running XP. It wasn't until 2005 that VMware first showed the idea of having the concept of a connection broker. By demonstrating a prototype at VMworld, VDI entered the limelight, raising the profile of the technology. It was also at the same event that companies such as ProPro showed their version of a connection broker. ProPro would later become the Horizon View connection server. In early 2006, VMware launched the VDI Alliances program with a number of technology vendors such as Citrix, HP, IBM, Sun and Wise. By 2007, the prototype connection broker was introduced to customers to help with development before it was given to the VMware product organization to productize it and turn it into a real product. The released product was called Virtual Desktop Manager, or VDM. 2007 was a busy year, and it also saw VMware acquire ProPro for $25 million in order to accelerate their connection broker development, leading to the VMworld announcement and release of VDM version 2 in January 2008. After the release of VDM 2 in early 2008, a second release came at the end of 2008 along with a new name, VMware View 3. This was also the year that Citrix entered the VDI market, releasing Zen Desktop. VMware View 4 was released in 2009 and was the first version to include the PCI over IP protocol. In 2010, View 4.5 was released with new features such as local mode, offline desktops, PCI over IP enhancements, Windows 7 support, and the ability to tier the storage. This was also the year that VMware talked publicly about the biggest VDI reference case to date with the Bank of Tokyo Mitsubishi, who deployed circa 50,000 virtual desktop machines. In 2011, View 4.6 was released with two notable new features. First, the iPad client, to allow users to use the iPad to connect to their virtual desktop, and the second feature was the PC over IP gateway for the View security server, which allows users to connect to their virtual desktop without needing a VPN. Later the same year, View 5 was released with even more new features aimed at improving the end-user experience. Although only a point release in May 2012, View 5.1 had a number of significant enhancements, especially around storage, with the introduction of the View Storage Accelerator, View Composer Array integration, and the ability to scale the hosting infrastructure up to a 32-node cluster if you used NFS storage. This version also added Radius two-factor authentication, improved USB support, and a standalone View Composer. In March 2013, View 5.2 was released, and to bring it in line with VMware's launch of the Horizon brand, it was renamed Horizon View 5.2. A second release later in 2013, Horizon View 5.3, saw the introduction of Virtual Dedicated Graphics Acceleration, or VDGA, which allowed a virtual desktop to have dedicated access to a GPU in the host server. It is also the first release to support Windows Server 2008 running as a virtual desktop machine. This meant that you could skin the operating system to make it look like a desktop. The main reason for this was that at the time there was no service provider license agreement or SPLA for Windows 7, so the license agreement didn't allow you to deploy Windows 7 as a virtual desktop until you purchased a Microsoft Virtual Desktop Access license. The final 5.x release arrived in March 2014 with Horizon View 5.3.1, which added support for VMware Virtual SAN, or vSAN. Horizon 6 with View was released in June 2014, and the core feature of this version was the addition of View-hosted applications, the first time VMware supported hosting applications and desktops using RDS. View 6 also introduced the Cloud Pod architecture, the ability to span the View infrastructure across multiple data centers. Also of note in View 6 release was the removal of View Local Mode, which allowed users to download their virtual desktop to the local device. Instead, VMware suggested that you use the Mirage product. As part of View 6, there are a couple of other updates. 6.0.1 in September 2014 added USB 3 support, extended printing and HTML access for Windows 8. The final 6 release, 6.0.2, was released in December 2014. In this release there was no update to the View infrastructure components such as the connection server, but it was built as a new feature pack. It added new versions of the View agent, HTML access, MMR redirection and scanner redirection. Support for NVIDIA Grid vGPU was the biggest of the new features in View 6.1, which was released in March 2015. Also in this release, VMware added support for IP version 6, Virtual SAN 6, Virtual Volumes, and Windows Server 2012. In June 2015, the final 6.1 release was launched, adding features such as client drive redirection, support for Linux desktops, and HTML support for hosted apps. That now brings us up to the previous version of Horizon View 6.2, launched in September 2015. 6.2 added support for Windows 10, access point integration, AMD VDGA, 4K monitors, and Virtual SAN 6.1, along with a number of enhancements to Cloud Pod architecture, the admin console, and Linux desktops. Following on from View 6.2, VMware also launched 2 maintenance releases, 6.2.1 and 6.2.2. That now takes us up to Horizon 7. Horizon 7 was first released on the 22nd of March 2016, with several point releases made throughout the rest of the year. 2017 saw Horizon move from 7.1 to 7.3, with 7.4 being released in early 2018, which brings us nicely up to today and the latest version, Horizon 7.7, which was released on the 13th of December 2018. So let's have a look at Horizon 7 in a bit more detail and some of its features. So what were some of the key features that were added throughout the releases of Horizon 7? Support for instant clones, the Blast Extreme protocol, increased scalability for Cloud Pod architecture, smart policies, URL content and client drive redirection, support for Windows 10 and Server 2016, enhancements to Linux desktop virtual machines, the Horizon Just-in-Time Management Platform, or JMP, which brought together not only Horizon View but also App Volumes and VMware UEM, the Horizon Help Desk tool, the ability to deploy on VMware Cloud for AWS, a new management console in the Horizon console, and true SSO and access point integration. And we'll talk about some of these features throughout this course.